Hi everyone, and welcome to the video lecture, Reconstructing Using Bloodstain Evidence. Let's get started. Like the previous lecture video, this video will contain some refreshers from Survey of Forensics. And let's start with the goal of bloodstain pattern analysis, or BPA. Bloodstain pattern analysis is a type of crime scene reconstruction technique that's useful to investigators in a number of ways. BPA can help investigators identify the type of injury sustained during an attack, as well as the minimum number of injuries sustained. BPA can also provide us with location information, including where each injury took place and where the victim and the offender were standing during the attack. BPA can also provide us information about other people in the scene. And finally, in addition to helping investigators recreate the attack itself, BPA is also helpful for determining post-attack movement of both the suspect and the victim within the crime scene. Now, bloodstains are impacted in a fairly consistent manner by the context in which they are formed. And there are four primary factors that will impact what the bloodstain will look like once it forms. First, the shape of a releasing surface is going to impact how large the bloodstain is. Smoother surfaces will hold blood onto them longer, and that results in larger drops. Drops from pointed or sharp surfaces are usually smaller in nature because less blood will accumulate before it drops off the surface. The second is the characteristics of the receiving surface that also change the bloodstain. Smoother surfaces are less likely to break the surface tension of the blood drop, so blood will remain spherical and result in a single circular stain. Rougher surfaces are more likely to break the surface tension of the blood drop, and that causes more irregular shapes and more satellite spatter. Bloodstains that are deposited onto non-porous surfaces will remain circular in shape, whereas bloodstains that are dropped onto porous surfaces will absorb the blood into the surface, and that causes the blood drop to also become misshapen. The third factor that influences the shape of the bloodstain is the distance between the releasing and the receiving surface. The greater the distance between the releasing and the receiving surface, the faster the blood drop will be moving, which means the more spatter will be created by the time it hits the surface. And finally, blood dropped at a 90-degree angle will remain circular because the force will spread the stain evenly in all directions. The smaller the angle between the force and the surface, though, the longer and thinner the bloodstains will become. This creates a tail on the end of a blood drop pointing in the same direction that the force was applied. And that's going to be something that's very useful during reconstruction. To help investigators reconstruct the events that caused the bloodstain, they will use the directionality and the angle of the blood impact to determine the approximate location from which the blood originated. Using the directionality only, investigators can determine the area of convergence, which is the two-dimensional identification of the location of impact. Adding in the angle of impact, investigators can identify the area of origin, and that's the three-dimensional location of the impact. This three-dimensional impact will not only give us the height and width of the impact location, but also how far away from the surface that the impact occurred. Now there are 5 steps to determine the area of origin. First, you want to select between 5 and 10 blood drops from a single bloodstain pattern to analyze. Now there is no magic number in terms of how many to use, but you want to make sure that you have enough drops to reduce uncertainty while also focusing on a single bloodstain pattern. When you're selecting blood drops to analyze, you should select blood drops from different parts of the stain pattern because you want representation from multiple directions. It's also recommended to select drops that are clear, well-defined, and not distorted, and don't overlap with other stains because that's going to give you the greatest accuracy. For that reason, typically blood drops towards the edge of the pattern are preferred, as these are less likely to be overlapped with other stains, and they have the clearest, most angled edges to work with. Now the second step is to identify the directionality of the blood drop, and that means you want to identify the direction that the force was moving when the blood was deposited onto the surface. This will allow you to work backwards, moving from the blood drop to the original location of the force being applied. To determine directionality, you want to examine the shape of the blood drop. Look for the pointed or the elongated end, also known as the tail of the bloodstain. This indicates the droplet's travel. Blood travels from the rounded edge towards the pointed edge. As you can see from this photograph, the tail points to the right, and that means that the force was moving from left to right. So if we want to find the original location of the force, we would look the left of the blood drop. Now the third step, measure length and width of the blood drop. Using a ruler or a caliper, measure the bloodstain's length from the leading edge to the tip of the tail. Then measure the width at the widest portion of the stain. Now a caution here, if a secondary droplet has detached from the parent stain's tail and formed its own satellite spatter further down, you don't want to measure from all the way there. You want to measure just to the end of the tail that's actually attached to the blood droplet you're currently analyzing. So here's an example of where the measurements would be taken on this blood drop. Since the full tail is attached to the parent stain, we're going to measure from the head of the stain to the very end of the tail to obtain the length. The width is measured by finding the widest part of the parent stain and then measuring from side to side. Step 4, calculate the angle of impact. The geometric formula here allows you to calculate the angle of impact by taking the arc sine, or the inverse sine, of the width divided by the length. Because we're measuring impact between two surfaces, typically the angle of impact will range from 90 degrees, which creates perfectly round droplets, to lower angles like 10 to 15 degrees. And these create very elongated droplets like the one that you saw on the previous slide. So let's put that into an example real fast. Let's go back to our original blood stain, and let's say that we measured and the width is equal to 1 centimeter and the length is equal to 5 centimeters. We would plug those numbers into our equation and take the arc sine of 1 divided by 5, plug that into a calculator, don't do it by hand, and that is going to give us an impact angle of 11.54 degrees. Okay, so then step 5, we're going to put this all together to string the blood trajectory. We know that the location of the original force was to the left of the blood drop because the force was moving from left to right when the blood impacted the surface. We also know that the angle of impact of the blood was dropped from was 11.54 degrees. Using a compass, we can string the path that the blood drop took through the air. To string a blood stain, you need to know whether you are calculating an area of convergence or an area of origin, because it changes it a little bit. For the area of convergence, the two-dimensional location of the impact, you're going to tape a string to the surface directly behind the tail of the blood stain, and then you're going to pull it across the entire surface so that the string crosses the blood stain from head to tail. Pull it all the way across the blood pattern and then tape the other end of the string to the opposite side of the blood stain pattern you're analyzing. You don't want to tape over the blood stain itself if at all possible, because the tape could damage the pattern, but the string can cross over the blood stain. If you're doing an area of origin though, which remember is the three-dimensional area of impact, you need to account for the angle of impact as well as the directionality. So instead of taping directly behind the tail end of the blood stain, you're going to tape directly in the front of the blood stain, in front of the head. That way the string starts at the first location where the blood impacted the surface. You're going to pull the string away from the surface at the same angle as the angle of impact, and then attach to a second surface across the way from the original. And that surface can be whatever you want. It can be other walls, a ceiling, it can even be other furniture like floor lamps and coat hangers to tape the string. For either analysis, one blood drop is not going to lead you to any final conclusions. Once you've done this last step for a single blood stain, you have to go back to step 1, select a different blood stain in the pattern, and start the whole process over. Remember to pull blood drops from different areas of the pattern. The location where all the strings overlap is going to be your area of origin in the three-dimensional space or your area of convergence in the two-dimensional space. Now, one of the major concerns with bloodstain pattern evidence is the documentation. Because of their nature, most bloodstain pattern evidence is not a single object that can be readily transported to the lab and entered into evidence themselves. Therefore, documentation at the scene is essential to preserve the information for future reconstruction. Documentation includes extensive notes, diagramming the full pattern and making note of all your measurements regarding the height, width, and droplet characteristics for all the droplets that you analyze inside the pattern. Photographing the stains is also essential. Because the photographs themselves will be used for the analysis, all photographs should have a scale in them. It's recommended to adhere a scale to a vertical surface before starting your photographs to ensure that there's a scale visible in all the photos, even those taken of the full pattern. You should also make sure that your camera is held directly perpendicular to the wall so that the sensor of the camera is parallel to the surface. And that's known as film plane parallel, and you guys have had lots of practice with that. Finally, documenting bloodstain evidence requires you to select multiple droplets and photograph them individually using examination quality photographs. So you should have the different droplets that you selected to string, usually 7 to 10 droplets per impact spatter. And you want to look for stains that give you good directionality, meaning that it's elongated in some way. And you also want to look for stains that don't overlap. So just remember, you want to document and collect enough stains to ensure that you've captured all of the potential spatter. All right, well, that concludes our video lecture on documenting bloodstain pattern evidence. Thanks for watching, everyone.